Ladies and gentlemen, welcome back to the Rakuten Booth Theater. Next up, we're going to be treated to a very special session from the President of the Cloud Business Unit, Partha Seetala. Please join us now to hear about innovation at the Telco Edge. Please give a round of applause for Partha, ladies and gentlemen.
Thank you. Good afternoon, everyone. I'll be presenting how you innovated the edge, because edge is a happening thing these days. You start to see a lot of compute moving closer to where the data is being produced or where the data is being consumed. But what are the challenges, before we get into how to solve those problems, what are the challenges that typically our customers see when they are processing data at the edge, right? Let's start with this. So a typical network looks like this. You have several servers, but those servers are not all centrally located. They're distributed all over the place, right? If you're talking about a telco network, you have the far edge where you essentially have your radio heads and you're running your baseband units there in the 4G and 5G. And then you aggregate down into regional data centers, and you have a bunch of regional data centers with servers inside that. And then you go up to the central data center, right? So this is your typical large network. Now, what are the challenges? I mean, people talk about using cloud-native technologies to solve these problems at the edge, but what challenges are there? So when we looked at our customer base and saw, what are the unique things that they are facing? There are 4 categories into which you can classify these. The first one is around, infrastructure. You have a volume of infrastructure components here, whether it is servers, network switches, and so on. So how do you take, hundreds and thousands of such infrastructure components and make it easy for deploying that infrastructure component, even before you can actually deploy applications at the edge? So that's the first challenge that needs to be addressed. The next challenge is, okay, now that you have your infrastructure up and running, which means that your servers are up and running with the right operating system and the right drivers and so on, you have to essentially deploy a platform on which you can run your applications. And traditionally, this platform used to be a very closed platform that used to come from your vendor. More and more, you start to see that this platform is getting, actually, 5 years ago, it was virtualized. You would see virtualized OpenStack-based or VMware-based stacks. Now you see a lot more Kubernetes and cloud-native-based platform that's coming up. But the challenge here is, when you're deploying these applications, if you look at the far edge, they are very latency sensitive. Let's say you're running RAN, very latency sensitive. So how do you set up the platform based on the needs of this application? Here it is latency sensitive. There it's maybe throughput sensitive and more, you need to be more in terms of utilization. You have to consolidate workloads and so on. So there's a challenge around how you deploy that platform. How do you ensure, security at that scale at which you're deploying? The third challenge that we see is services, right? Once you've deployed the platform, the infrastructure in the platform, how do you actually deploy the services that are running on this? Because these services could span from, as you can see here, the network function here, there, and there, and you're going to stitch all these network functions together. That forms your service. Now, when you're distributed this way, how do you make it happen, right? That's the third challenge. And the last one I say is in the operations. You have a large-scale deployment, both in terms of infrastructure and services. You need to get a bird's eye view. You need to know what has failed. If something has failed, you need to understand how is that failure going to cascade down your network and so on. So this is traditionally what we have seen as the 4 categories of issues that need to be addressed if you're deploying things at a distributed scale or a large scale in a distributed manner at the edge, right? So before we jump into what we have done at Rakuten, I just wanted to give you an idea of, what an ideal solution would look like, right? So the number one thing is, you want to have a platform that enables you to deploy your network functions in a matter of minutes. Like typically, we think about weeks and months as, how long it takes to deploy applications. But what we have seen and what we have actually built at Rakuten Mobile or at our other partner or customer 1&1 is we can actually deploy applications in a matter of minutes and hours. That's the first one. The second one is, how do you deliver this high performance and low latency with predictability? Why is that important? Because servers are getting more and more beefier year over year, which means that they have more juice, and you're essentially packing more applications onto the same server. Now, when you pack more applications, you're consolidating. That's great. It increases your utilization, but it also causes, spikes in performance because you don't have isolation between these applications, right? So how do you essentially get that high performance with low latency with predictability, right? The ideal solution should be able to cater to address to that. The next one is, when you have scale, you want to actually not throw more humans at solving the problem of, managing infrastructure and services at that scale. You want automation, right? So how do you essentially get let automation rather than human workforce handle, management at this scale. And the last one is how do you essentially drive TCO benefits, right? So with this background in mind, I just wanted to share what we have built at Rakuten and what our customers are really embracing. So the product lines that we have fall under a category called Rakuten Cloud. It's not a public cloud. Cloud essentially might signify that it's a public cloud. It's not a public cloud setting. It's a private cloud that you would go deploy in your own data center. And it can be deployed either at your central data center or all the way at the distributed edge. And we are specialized in solving for what we call as stateful workloads. And what I mean by that is workloads where there is a lot of network traffic going on, where you have low latency requirements. That would be your typical RAN core kind of applications, or applications where there's a lot of storage state, right? Which could be your big data platforms or databases that are backending your other network function workloads, right? So that's where we basically specialize in. And the three products that we offer, the first one is what we call as Rakuten Cloud Native Platform. So this is the industry's, in fact, it is the first Kubernetes distribution in the industry that was specially made for stateful workloads, network-centric and storage-centric stateful workloads, delivering the highest performance, both in terms of network latency as well as storage IOPS throughput and latency. And I'll go into more details about that in a few slides. The other one that we have is called as Rakuten Cloud Native Storage. So the Rakuten Cloud Native Platform actually integrates a storage stack. But some of our other partners basically said that, okay, we want your storage stack so that it can work with other Kubernetes distributions. So we essentially separated the storage and we ship it with, other Kubernetes distributions as well. And this is the industry's highest performance application-aware storage stack. I know it's a very packed, loaded sentence. I'll actually unpack it in the next slide. The third product line that we have is called as Rakuten Orchestrator. This is basically a, infrastructure to service orchestration platform that enables you to take bare metal servers, convert them into fully functional Kubernetes clusters, and on which you can essentially deploy network services, right? Okay, so let's just dig a little deeper into all these three product lines and what capabilities they have and how we are different from, a plethora of other options that, you would have as a customer. Let's start with the cloud native platform. So at a very high level, if you think about it, right, there are at least, I would say, 20 to 30 different Kubernetes distributions out there. And quite frankly, the world does not need another one, right? So why do we exist and what is it that we do, which is different? As I said earlier, right, if you look at Kubernetes platforms today, they are mostly designed for just making the life of an administrator easy or a developer easy to deploy containers. And as long as those containers are stateless, which is just business logic, they don't have storage and network state, it's great. But what happens if you have network state, right? Or what happens if you have storage state? The failure possibilities are higher. And especially, let's say you have a storage application, it fails, a disk fails. How do you fail over that application from a faulted server to a healthy server? That's a big challenge, right? Kubernetes by itself does not solve that. And the way we address that is by essentially adding capabilities around Kubernetes. So let me start with, this side here first. So we built what we call as the first application-aware storage stack. So what does that mean? So when you look at storage, typically the way it was done before the Kubernetes era was that you would buy storage arrays from storage array manufacturers, whether it is a NetApp or Pure Storage, EMC, and so on. When Kubernetes started to happen, essentially what the customers and the deployment and the ops team wanted was that they wanted the storage to be consolidated or co-located with where the applications were running, which is they wanted a hyper-converged storage and Kubernetes stack. Now, when you do that, what is really happening is you don't have your traditional storage administrators managing storage anymore. You have your generalist DevOps people or site reliability engineers managing that. And they do not know anything about the intricacies of storage. Let's say a disk fails. How do you recover? Let's say data gets corrupted because there's a bit flip on the disk. How do you recover? And you cannot expect these SREs or the DevOps engineers to become storage experts. So we had a radical thought almost 7 years ago. We said, what if you make the storage stack actually aware of applications? What does it really mean? It essentially means that if the storage stack can understand the performance, the availability, and the topology requirements of the application, right, then it can automatically program itself to ensure that data locality between compute and storage is given so that you can meet the low latency needs. It can anti-affinitize different services so that if a server fails, you don't have a single fault domain and so on, right? Now, as an extension of that, what would happen is you would essentially have generalists be able to manage this complex domain called storage. So we were the first in the industry to build something like this, and we have a lot of IP around this space. And by extension, what we were able to do is that we also made day two challenges that exist with storage a lot more easier. I'll go into what I mean by that in another slide. But that's the first component. The next one is networking. So networking is also a challenging thing with cloud-native applications. It gets even more challenging if you're deploying low-latency network functions. Let's like DU or CU or packet core and so on, right? So what we have done here is the same innovations that we had with application awareness and storage, we brought that to networking. And the way we did that is the platform, which is the Rakuten Cloud Platform, we do a discovery of the capabilities of the underlying hardware. Does your network card have, let's say, SR-IOV capabilities? If they do, and does your application need that? If it does, then what we do is instead of telling the application vendor or the ops teams to go and program that together, we just say, drop in a policy that says, I want this kind of latency profile for my application. This is the kind of isolation guarantees I want. This is the kind of network connectivity to the backhaul, midhaul, and management control planes. And we just go and program the underlying network, right? All the way from the NIC card and to how the compute basically uses that, right? In terms of CPU binding and so on. And there's a lot of work that we have done in terms of, supporting what we call as layer 3, stretching into the Kubernetes network namespace and stuff like that, which makes connectivity a lot easier. Things around static IP addresses where, when applications fail over, we migrate the network identity of those applications. And if you are doing network functions, these are very critical things, right? And on top of that, we build this application workflow manager that ties everything together. And what this does is actually it programs the underlying Kubernetes stack, the storage stack, and the networking stack so that the administrator of the ops team do not have to do anything, right? In terms of manually configuring, the infrastructure to meet the needs of the application, right? So with this, we have built a platform that today powers actually the world's largest 5G deployment, fully containerized 5G deployment. It actually is deployed today at a very massive scale, managing multiple petabytes of data, right, in production environment. The platform itself is designed in such a way that you can run both containers as well as, virtual machines on the same platform. And there's a lot of innovation that we brought here where even virtual machines look like containers to the Kubernetes stack, but they actually are virtual machines, so you can actually deploy VNFs unchanged on this platform, right? And it is designed for not just day one, which is just deploying an application. This is designed for day two, which means that when there are failures, there's automatic handling while ensuring that the placement policies are honored when components fail. Right? So that's the first product that we built. It's called Rakuten Cloud Native Platform. Now going to the next one, which is the Cloud Native Storage Stack. What we have done here, as I said, right, it's the industry's first application-aware storage stack. We looked at the world of storage in two different ways, right? There's the day one or day zero or day one, however you call it, where you have to provision storage. And in day zero, day one, what you really are focused on is, I want certain capacity, I want certain performance, right? And I want certain availability. I'll throw a bunch of servers with disks in them, you pull that capacity together and give me that storage and bind them to the application. Perfect, right? And as I said, it is the fastest performing storage stack in the industry today, cloud native storage stack today. But then comes day two. In day two, you have to think about when you have storage, you have to think about backup, you have to think about snapshotting, you have to think about recoverability, right? You have to think about capacity expansion while the applications are still running. That's all baked into this product. Now, just to give you an illustration of what that means, if you look at it, we support things like snapshotting a fully running application in a matter of milliseconds, right? We essentially support cloning, which means that you have your application running. We can create a test dev clone in your test dev lab or, other places. We can back it up. We can do multi-cloud portability, which means that you can essentially run your workload in one cluster. And along with that state, you can migrate it with one push of a button. If you're doing it from the UI, one command line if you're doing it from the CLI, or one single API, regardless of how complex that application is, how many components it has, and how much storage it has. With one click, as we call it, we can migrate an application from one cluster to the other, or one environment to the other. This storage stack today, as I said, is managing several petabytes in production environment. And it is also, in addition to being deployed in the traditional telco edge, it's also deployed at the retail edge customers. In fact, one of the world's largest retail edge customers actually has this stack, the storage stack deployed. The last product line that we have is infrastructure orchestration, or what you call as Rakuten Cloud Native Orchestration. So the first two products that I showed you, right, the first is a platform, which means that if you have network functions or other types of applications, you can run them in a very resilient and high performance manner. The second one is managing the storage. But before all of these things, you actually have to manage infrastructure, right? Because you need somewhere where this thing runs, right? And there is a problem of scale here. Again, let's go back to the first picture I showed you. The traditional networks looks like this, right? Now, do you think if you have tens and thousands or hundreds and thousands of servers, do you think a human will be able to go manage this? They can't. The sheer time it takes and the complexity and the errors when you start doing things in an automated manner just makes it more complicated, right? So what we did is that we built this product called the Rakuten Cloud Native Orchestrator. Starts with the infrastructure layer first. And what it does is you just register a bunch of bare metal servers with us. There's no need for an operating system also to be installed. Just register it with us. We use the Redfish APIs or any, server-specific APIs. We discover the capabilities, and then we install the operating system. Now, installing the operating system depends on the type of workload you're running. If you're running, for example, in the telco, you're running DU workloads, it has to be real-time kernel, right? Or if you're running basically a workload that requires GPUs, you have to install the right drivers, NVIDIA drivers. So you can essentially create profiles, and those profiles can basically lead to doing an automated install of all your bare metal servers. Now, this is done at a massive scale in production today. And what we are able to do with this is, as your servers are coming in and they're loaded, you can essentially convert them from metal bricks to fully functional running servers with Kubernetes installed the way you would like to run the workloads on top of that Kubernetes cluster. That's the first one. The second one is, now that you have this entire thing set up, obviously you like to orchestrate services. And those services could span multiple, the far edge to the regional edge to the centralized data center. So you could create, with the drag and drop, you could actually create a workflow diagram and say, this is my network service and I'd like to chain it this way. And with a click of a button, we enable that. Excuse me. And once it's deployed, we also make the life cycle of these applications automated, like in terms of upgrades or in terms of scaling up, scaling down. All of that can be automated. And the last the component or the last use case or capability of this product is that once all of this is running, you want to have a way in which you would like to run an automated script against all of these different entities, right? So you can essentially enable that as well. So just to summarize what we have built in terms of managing your applications at the edge with high performance and at a high scale, we have this platform. As I said, it has everything built in. In terms of not just the tech, but also in terms of licensing, in terms of packaging, it's just one software with one license. It's not licensed by feature. It's not licensed by this one license. And it has all these capabilities around storage, networking, automation, CPU, GPU management. Right? We have, in fact, a very large deployment of AI ML workloads where those workloads need things like GPU slicing. All that capability is built in. With one single license, you get all these capabilities. And then we have the same platform runs both containers and VMs, as I told you. And again, there's quite a bit of innovation that we have done in terms of how to run VNFs. If you're familiar with the Kubernetes world, people who talk, they know things like KubeVirt. We actually innovated on top of what KubeVirt actually offers, natively. If you're interested, I can talk about that offline. Then we also have this multi-domain orchestrator that is packaged as part of the solution that enables you to take, as I said, bare metal bricks, convert them into fully functional, units of compute and storage. The centralized observability is very critical when you're operating at this scale. So this, ladies and gentlemen, is the solution that you have built for managing your applications at scale. Thank you.